Professor Adesoji Adesina was born on April 2, 1959 to the late Chief Adolphus Adesina and Chief Mrs. Bernice Adesina, both of Ijebu-Igbo, Ogun State. He attended Lagelu Grammar School, Ibadan, where he obtained the West African School Certificate with a Grade 1 distinction in 1975. He then proceeded to the University of Lagos, from where he graduated with first-class honors degree in chemical engineering in June 1980. He obtained a PhD in 1986 from the University of Waterloo, Canada, with a Canadian Commonwealth Scholarship Award. He returned to the University of Port Harcourt as a lecturer in the same year. His passion for research eventually led to a Natural Sciences and Engineering Research Council of Canada funded research associate position at the University of Waterloo in 1989. In 1991, he joined the University of New South Wales, Sydney, Australia as a lecturer and rose to full professorship in 2004. At UNSW, Professor Adesina initiated and developed an internationally renowned group in reactor engineering and technology. A distinguishing characteristic of his research accomplishment is the ability to mesh different levels of granularity to secure optimal process design and implementation from conceptual roots. This holistic approach and skills concentration is rarely found in a single research group and has been an instrument to the successful operation of innovative process technologies. His research activities may be subsumed into three categories, namely energy, environmental and wastewater treatment technologies, process intensification, and interdisciplinary work. Under energy, the activities in this category cover both fossil fuels and renewable energy sectors. Professor Adesina's research has elucidated effects of dynamic fixed-bed reactor operations on product selectivity. He also pioneered the application of electrical capacitance thermography for the diagnosis and control of high-pressure slurry Fischer-Tropsch reactor ring. An important dimension of this development is the provision, for the first time, of an explicit mathematical relationship between fluid phase characteristics and reaction metrics. Furthermore, he developed a novel thermally self-sustained fluidized bed reactor for light alkane reforming. This inventive strategy permits a higher hydrocarbon to stem ratio in the process feed and hence superior carbon economy than current industrial practice allows, while simultaneously achieving reduction in overall energy consumption and greenhouse gas emissions. In the renewable energy area, Professor Adesina has focused on the exploitation of biotransformation chemistry to optimize efficient reactor design for biofuels production from agro-waste. This demonstrated in the patented extractive reactor technology for the continuous flow production of biodiesel from spent cooking gas. Amongst other advantages, this new process uses dilute ethanol solution 15% rather than expensive 95% rectifiate employed in current practice, while concurrently removing glycerol byproducts from the reacting phase to produce high purity 99% biodiesel. As a result of the novel integration of the reaction and separation steps into a single unit, the overall plant economics for the new technology is about 50% cheaper footprint and capital cost than existing industrial biodiesel manufacturing process. Till date, Professor Adesina is credited with over 450 referred publications, patents, and books. He has supervised more than 100 graduate students to completion, including 45 PhD alumni with a truly global hue. Among these former students are university professors in highly ranked institutions, executives of the petrochemical processing industries, government dignitaries, and captains of engineering design and consulting firms located throughout China, Southeast Asia, Middle East, Europe, USA, Canada, and Australia. He has won $15 million in competitive research grants from government and industry sponsors.
He is a fellow
of the Nigerian Society of Chemical Engineers and the American Institution of Chemical Engineers, UK, and Royal Australian Chemical Institute. It is for his services in engineering, his academic and professional contributions in chemical engineering, the education training of chemical engineers, as well as promotion of chemical engineering skills and excellence in the area of research in the use of local materials that in 2017, Professor Adesoji Adesina, quite yet efficient scholar and a very able professional engineer,
was awarded
the Nigerian National Order of Merit.
Ladies and gentlemen, let's make welcome the first award winners lecturer 2019, Professor Adesoji Adediran Adeshina, NNOM.